The damage to their daughter's car, they couldn't figure out what happened.
We were all just shocked. We had no idea what happened. We thought maybe something fell from the sky or something like that.
And when they got a look inside, they were still without answers.
It looked like a tornado hit the inside of the car.
Until they realized this white residue was actually dry shampoo. And 50 feet away, they found a can of dry shampoo that was missing the bottom piece to the can.
And that had happened when she'd gotten in the car after work or gotten in the car to go somewhere. The glass itself would have been devastating.
Christine says the explosion was so powerful, her daughter's center console lid had been blown off the hinges. Her daughter just bought the car 3 months ago and used her own hard-earned money to pay a hefty down payment.
Terribly upset. She looked hard for a car that she wanted and could afford. And it's a real sporty
While ago, we are dealing with the relationship of temperature and pressure in terms of fixed volume. So with that video, the explosion takes place because of the increase of temperature, because of higher kinetic energy inside a fixed volume also increases the pressure. And with that, explosion takes place. And this phenomenon was greatly explained by none other than a French chemist, Joseph Gay Lusaac, during 1778 to 1850, wherein he pronounced and discovered the relationship between the pressure of a gas and its absolute temperature. We all know that the absolute temperature unit is term of Kelvin. So Gay-Lussac's law or Gay-Lussac's law relates states the relationship between temperature and pressure if there is a fixed or constant volume. And temperature and pressure have direct relationship. So when the temperature increases, its pressure or those part of the molecules that have a collision in their container also increase. And they have mentioned that pressure over temperature is directly proportional with this statement. So this is our general equation. Let's try to solve a problem that involves a Gay-Lussac law. On the side of the aerosol cans, there is a warning against heating the container. If the gas inside the container is at pressure of 5.9 atmosphere, if there is a pressure and temperature, let's try to put the given here. So sabi natin there is an initial pressure of 5.9 atmosphere and its temperature should be 22 degrees Celsius at room temperature. What will the pressure of the can be if the can is heated to 100 degrees Celsius? The question. So we need to change first the degree Celsius into Kelvin by using the formula Kelvin is equal to degree Celsius plus 273. So for our first temperature, we have degree Celsius or 22 degrees Celsius plus 273. So 22, 22, we have 3, 4, 5, 7, 8, 9. So we have 295 Kelvin. For our T2, we have 100 degrees Celsius plus 273. So napakahirap. It was quite hard for us to perform mental math. Of course, the answer is 373 Kelvin. So our unknown is the change when the result, when we change the temperature of the can to normal temperature to 100 degrees Celsius, what will be our new pressure? So the formula is we'll get the statement of pressure initial over temperature initial is equal to pressure final over temperature final. So to solve this problem, all we need is to plug in the value. So pressure 1 is 5.9 atmosphere divided by our initial temperature, which is 295, Kelvin, am I correct? Which is equal to our pressure 2 is unknown all over temperature 2, which is 373 Kelvin. Then we need to perform cross multiplication. So P2 multiplied by 295 Kelvin is equal to 5.9 atmosphere multiplied by 373 Kelvin. Then we need to divide both sides of our equation by 295 Kelvin and 295 Kelvin as well on the other side to cancel it out. The value of our new pressure will be, using our calculator, 5.9 atmosphere, 5.9 atmosphere multiplied by 373 divided by 295 Kelvin. And the answer is 7.46. 7.46 atmosphere. So this will be our new pressure when we change, or we hypothetically change, the temperature into 100 degrees Celsius. Okay? So that's how we solve a problem. Looking back with our problem, or we looking back with our data, it is 7.46. We probably says that we are correct. As we change the temperature into higher one, the pressure also increases. Okay? So that's how we solve a problem that involves the Gay or Guy-Lusac law. Thank you very much for watching.